Today, we're diving into an incredible feature that's built right into SQL Server. I'm talking about something that literally acts like a time machine for your data. It's called Temporal Tables, and it's a game-changing way to automatically track the entire history of your records. You know that feeling, right? That absolute heart-stopping moment when you realize a massive update statement just ran without a where clause? All that critical data just gone. What if you could just rewind the clock on that table and see exactly what it looked like 5 minutes ago? Well, you can. So here's how we're going to break this down. First, we'll talk about why you'd even want to track data history in the first place. Then we'll get into what temporal tables actually are and, how they work under the hood. We'll even query the past, which is the fun part. Then we'll cover the good and the bad, the powers and limitations, and wrap up with how this can be your data's brand new safeguard. Okay, so before we get into the tech, let's start with the really important question, why? Why bother versioning data? Turns out it's not just some nerdy technical exercise, it's driven by some really common and frankly, critical business needs. Just think about it for a second. Auditing, right? You absolutely need to know who changed a customer's credit limit and exactly when they did it. Or how about data recovery? Being able to restore that one super important row that got deleted by accident without having to do a massive, stressful restore from a backup. It's also huge for data warehousing, for tracking things like a customer's address over time, and for any developer out there, it is an absolute lifesaver for figuring out how on earth your data got into some weird, unexpected state. For years, we developers had to build our own, often clunky solutions for this stuff. But ever since SQL Server 2016, there's a much better way. So let's talk about the modern, built-in solution, temporal tables. The old way? Oh man, it usually meant writing these complicated triggers. Every time a row got updated or deleted, a trigger would fire off and frantically copy the old data into some other history table. It worked, sure, but it was a maintenance nightmare. The new way is just so much cleaner, it's built in, it's automatic, and it means you get to write way less code. It's a huge win. So what exactly is a temporal table? Put simply, it's a feature where SQL Server itself does all the hard work of keeping a full history of your data changes. You don't have to code it, you just turn it on. That's it. It just works. All right, so the theory is awesome, but how does this thing actually tick? Let's walk through creating one right now. You're going to be surprised at how simple this actually is. Okay, here we have a pretty standard create table script for a customer's table. You've got your ID, name, city. Looks normal, right? But look closely at those last few lines. There are a couple of key pieces here that magically transform this from a regular table into a time-traveling one. Let's break them down. First thing you need are these two new columns, sys_start_time and sys_end_time. Think of these as the bookends for a row's lifespan. The system manages them completely, and they basically say, hey, this specific version of this row was the current live version between this start time and this end time. And here it is. This is the magic switch. This little clause, with system versioning equals on, is you telling SQL Server, okay, start tracking history for this table. Now, you also give it the name of a history table, and get this, if that history table doesn't already exist, SQL Server will just create it for you. How easy is that? Okay, now for the really fun part. We've got our tables, let's throw some data in, make a change, and watch this time machine fire up. Right, so we've just inserted 3 new customers. Now, the interesting thing to look at here is that sys_end_time column. See how it's set way out into the future? That's SQL Server's way of saying these are the current versions of these rows. They're valid right now and will be, well, basically forever, until something changes. And if we peek into our history table, dbo.customershistory, yep, it's totally empty, which makes perfect sense, right? We haven't actually modified or deleted anything yet, so let's go ahead and change that. Okay, here we go. A simple update statement. We're changing the cities for customer number 2 from Denver to New York. Now, behind the scenes, SQL Server is about to do something pretty brilliant. So, first, let's look at the main customers table again. And just as you'd expect, customer ID 2 now lives in New York. This table always shows you the absolute current state of your data. But where did the old Denver record go? And there it is. This is the magic. The old version of the row, the one where the city was Denver, was automatically and instantly moved over to our customer's history table. SQL Server also stamped the sys end time with the exact moment that row stopped being the current version. It's all done for you. So how do we get at that history? This is the best part. You don't even have to query the history table directly. You just query the main table like you always do, but you add this new clause, for system time as of, and give it a timestamp. SQL Server then does the work of piecing together what the data looked like at that exact moment. It's so simple, it's brilliant. Look, this feature is fantastic, but it's not pure magic. There are some specific rules and limitations you really need to know about before you go and flip this on for all your production tables. The upsides are huge. The tracking is totally automatic and transparent. Your application code doesn't even need to know what's happening. Recovering data becomes ridiculously easy. If you add a new column to your main table, SQL Server adds it to the history table for you. And maybe best of all, you can put your own custom indexes on that history table to make your historical queries super fast. But you gotta play by the rules. Your main table must have a primary key. That's non-negotiable. You also can't truncate a version table. You have to use delete. The history itself is sacred. You can't change it directly. And if you ever want to drop the tables, you have to explicitly turn versioning off first. Honestly, a lot of these aren't really limitations. They're smart safeguards to protect your data's integrity. So, when you put this all together, what do you get? You get an incredible, built-in safety net for your most critical data, and you barely have to lift a finger to set it up. This quote really just nails it. Before this feature, recovering a single row that was accidentally deleted could mean a full-blown, high-stress restore from a backup. Now, it can be as easy as running a simple select to find the old data and an insert to pop it right back in. The difference is night and day. So the real takeaway here is that you have this incredibly powerful tool just sitting in your SQL Server toolbox waiting to be used. It makes auditing a breeze and data recovery almost trivial. So the only question you should be asking yourself right now is, which critical table in my database, my customers, my orders, my products, needs a time machine?